Now you're not restricted just to the functions that are already present, okay, in R. You can set up your own function, like the lambda functions that we saw. Okay, suppose we, okay, all right, now let's see, we want S apply, right, and empty cars, okay, and then you say function. Okay. Function x, no comma, sorry, function x, and then you specify the function within curly brackets. So what this will do is it will take each column of empty cars and then send it to that function. And x is now, okay, one column of empty cars at a time. Okay, so coming into that function. Then now you can say what needs to be done. Suppose if you say I want sum of x squared, so that's going to square each item, okay, square it and add it. Okay, so for each column in empty cars, this function will be applied. Instead of mean or median or mode or whatever, this will be applied to that. And this operation, this capability is very useful in performing transformations. And oftentimes in data analytics, especially when model-based prediction methods, oftentimes we may want to standardize data because the magnitude of data, so one variable may be in the thousands, another variable will be in the tens. The variable with larger magnitude in a model-based procedure will have a lot more influence than the variables that are small relatively. So to even the playing field, right, we definitely want to standardize the data. And a couple of standardizing data that is often used is, one is z-score and the other is range standardization, which is you standardize the data to be between 0 and 1. So z-score, you know what it is, right? X minus x bar divided by the standard deviation. So the function we want, okay, so we're going to do S apply. Okay. All right. So empty cars. Then the function we want is actually, the standardization, it can be, you don't have to do it with S apply. There are other ways of doing it also, which is probably even simpler. But here I'm going to illustrate how to do this, apply L apply and S apply with a function, which is this. So you have x minus mean of x. Remember, x is one column at a time coming into this function from empty cars. So in the column, each value of x, and then subtract from it the mean of all of x, right? Okay, there. Okay. And then you divide by SD of x, standard deviation of x. Okay. Now let's do this just for one. I probably made a mistake. Okay, I guess I don't have to. Oh, there you go. I didn't have to give a comma there. Now, when you do mean, oftentimes you want to include, okay, if the column has missing values, then you want to say NA dot RM. So NA is missing value, RM is remove missing values equal to true. So that way you don't get an error. If there are missing values, and if you do mean of a column, since there are missing values, what you'll get back is a missing value. So you don't want that. Now, range standardization is you take the value of x and subtract not the mean but the minimum value, and then divide by the range. The range will be maximum minus minimum. So that is called range standardization. Okay, so this will be like S apply. Of course, right now I'm not capturing it back into a variable, so it's just doing the operation and it's all gone. But you need to capture it and then use it. So S apply empty cars, and again let's just do for one variable. Okay, function x. Okay, so what do you want for the function? It goes into curly brackets, x minus min of x. Okay, so that's the numerator. Okay, and in the denominator we want the range. So that will be max of x, right, minus min of x. Now, this transformation transforms the data to something between 0 and 1. Whatever the data may be, it's transformed into a corresponding value between 0 and 1. That's your range transformation. And z-score standardization, it converts them into z-score. Z-score will be like what? Theoretically it is minus infinity to plus infinity, but mostly it will be between minus 3 and plus 3, maybe a little bit broader than that. Okay. Log transformation. Okay. Suppose if you have data that is spread out over a large range, but a whole lot of data is squished into one end. Okay. In that case, you want to expand it out so there will be more space between the points, and log transformation is useful for that kind of situation. So do S apply, okay, again empty cars. Okay, so this time let's use 3 of them, MPG, HP, and weight. Okay, and I should have here square bracket, empty cars, square bracket, right, and then function x, and then within curly brackets. So for log, so here are the different log functions that are available. Just simply log will give you natural log, log10 will give you log base 10, log2 will give you log base 2. So usually natural log is what is used. So there you go. And any other transformation that you want, you want to transform into exponential, or you want squared or cubed or anything that you want to do, you can put it there. And you can also, there is one more important point, okay, if the function is a little more complicated, okay, it's not just one simple thing, then you can define a function outside, like what we have done previously, give it a name and define it, and then use that name here instead of defining the function itself within apply. You can put the function outside, give it a name, and then use that name here in sapply.